Thank you very much, everyone. So glad to be here. Yeah, my name is Tilen, and I'm leading the technology department at Outfit 7 Barcelona. So actually, this talk today is about to briefly introduce the process of making games at Outfit 7, and also to present what is the role about of an software engineer in gaming industry, and also a quality assurance engineer in gaming industry. So first, a couple of words about me. I come from Slovenia. I currently live 2 years in Barcelona. So I studied computer science, and after this I was working as a software engineer myself, and I gathered around 11 years working as a software engineer. So at first I was actually a full stack engineer. So I was working for an insurance company, and we were doing databases and developing desktop applications. And then I switched jobs, and in this company we were working for an electrical institute and also developing back-end software and statistical front-end applications, and also software to generate reports for power plants. So then I switched the industry. When I joined Outfit 7, only then I joined the gaming industry. So in short, how I experienced this, so it was like something way more fun and cozy. This, as I call it, the hoodie and the jeans outfit culture, right? And it personally gave me this indie vibe if I compare it with my past background. So at Outfit 7, I was at the beginning working as a software engineer, and I was programming features for games, so on about 6 different games. So I was implementing mini games, and I was also then a lead developer. And then slowly I started to manage other software engineers as well, and this was growing. So then I was actually managing, let's say, a whole team. And about 2.5 years ago, then I switched completely to the tech director role. So it was then purely managerial role, right? So then I was still working in Slovenia, and I was leading then transition soon after I switched the role. So I was leading the transition of 2 established projects from Slovenia, from our Ljubljana office to Barcelona, and then we continued here. And after that, I took over leading like the whole technology department in Barcelona studio. So altogether, I am 6 years currently working at Outfit 7. All right, so a little bit about the company itself. So Outfit 7 is the entertainment company that created the Talking Tom and Friends franchise. We currently have something more about 400 employees from 31 different countries. We have 5 offices, and 3 of them, we call them as the gaming studios, because there is the games production pipeline in, and that's in Ljubljana, Slovenia, Barcelona, and Limassol on Cyprus. And apart from that, we have also offices with support function, being in London and Beijing, where we have we do things like marketing purposes and for the partners relationships in those markets. So regarding the downloads, altogether we have accumulated like 17 and more billion of downloads with all of our apps. And in this year we have about 470 monthly active users. We are among the top 5 publishers worldwide in the last 6 years. Apart from that, we have also entertainment parks in China, because our owner also is a Chinese company. And we have also the global merchandise program, so to buy online toys, books, blankets with the Talking Tom and Friends franchise. And apart from that, we also do the animated series. So they are airing on Netflix and YouTube, and also on national TVs. So now I would like to show a really short video just to kind of wrap up like who we are and what we do. So let's take a look. All right, so just a little bit about our mobile games that we did. So everything started with the virtual pet games, and the first hit was the Talking Tom game. So it's about the cat repeating after you, and there are like plenty of pranks and funny stunts that the players can do. And we also made like other talking pets games with other characters. So then we developed this further, and we started to create the Tamagotchi games, right, without characters. So for example, My Talking Angela and My Talking Tom, they're this Tamagotchi games. So you wash and feed the character in there. You play with the character. Also, My Talking Tom and Friends game introduced all of 6 characters. And you interact with all of them. And in those games, you customize rooms and wardrobe and play mini games. And then we have this other tier of another genre, the runner games. So those are the endless, those 3-lane runners when you swipe left and right, right? So in Talking Tom Gold Run, so it's this left icon here. You collect gold bars, you build the house, unlock other characters, and you buy and unlock skins for them, and you chase the raccoon that stole the gold. Then we have the Talking Tom Hero Dash. In this game, we introduce the superpowers for our characters, and you repair the world of the mess that the raccoons cause, and you fight those raccoons in the gameplay. So then we have another tier of games. It's more mid-core RPGs, and it's with different IP intellectual property or different universe, so some other franchise, right? So the Swamp Attack, it's a game that you shoot enemies coming from the right, and you unlock and buy weapons. And then we have the Mythic Legends. It's a strategic battles arena game type, and you unlock heroes and spells, and you compete in the tournaments. So now I would like to talk about the departments in our company, just to give a perspective, which are all those different disciplines and crafts that usually a gaming company has. So we have art. So art makes the visual aspects of the game. Then we have the tech. So it's, of course, the software engineers and quality assurance engineers that we will learn more about them later. The producers, so they organize the production pipeline. So they align other disciplines that participate in the development and make the milestones, and we align around of them with the help of producers. Product management, they define the vision of the game on a high level, so what the game is about. Marketing, so they strive to bring product awareness to as much users as possible and in the most appealing way. Then we have the data and analytics. So they gather the data of how our players are doing in the games to learn out of these KPIs. App sales, they drive the user acquisition. So we also show ads for our games in other games in order to increase the user base. Then we have the ad monetization. So it's a department that focuses on researching and developing everything needed to bring the revenue into our games. Business intelligence researches the market and figures out like how different genres are doing and which one we should explore. Media content, they create the game trailers and videos for teasers when we launch a new game. Licensing, they cooperate with the partners for those toys and merchandising program. And of course, HR, So this department takes care of all employees and nurtures our culture. The IT, they take care of the tools so that everyone has whatever is needed to make the games. Of course, legal, they take care of all these agreements and compliances and intellectual property. Accounting, they take care of payrolls and rewards and stuff like this. And the project management to make project plans for, in general, all projects, not just the games, and evaluate risks and calculating costs. So who participates in the production of the games itself, hands-on? It's art. And this department breaks down further into 3D, animation, concept art. So for this area, also my colleague Grega will explain more in the next class. So everyone invited, also from our side. Then we have sound and UI and VFX, right? And there's the technology. So the software engineers and quality assurance engineers on the games, and also on departments like just for iOS, native code and stuff like this, and then also for Android. And apart from that, technology also covers on backend. So of course, every game has some server-side configuration assets, and this department further develops this. Then for directing the whole production, there's the game producer, and the product management also is very heavily involved in making of the games. So this department breaks down further into product, game design, and user experience, so the UX designer. So those are the departments that are really hands-on on the making of the games. Now, I would like to talk more about the process, so how we operate and how this looks to make a game, how we are organized. So let's talk about the production flow. So now we break down making of the game into, we call it the game lifecycle, and we break it down into phases. And everything starts with the ideation phase. So this phase lasts between 1 and 3 months, and we explore different product ideas and game mechanics. So here we have to figure out what the game, the next one, will be about that we're going to make. And the output is usually this game sketches, defined meta or core loop, and a prototype, so that those participating already here can get a hands-on on something to quickly check themselves on the devices. So then we move on to the concept phase. It lasts about 2 to 3 months. And here we explore different gameplay features within this selected game vision that we defined before. So the output here is prototyping those features to try them out in this phase, and we already figure out the monetization vision, so how this game is going to bring money, and the economy, let's say the in-game resources that make sense for this game that we decided to do. Then we move on to pre-production. So here everything starts to get more serious. So it still lasts between 2 to 3 months, and here we make the plan for the production. So here we develop this GDD, right, the game design document, and it contains like all the features specified that we are about to implement. And here we also figure out how we are going to do those features. So we explore different techniques and we try them out in this pre-production phase. And also we define the timeline. So when are we going to start with the production and when we're going to finish. And the output here is, we call it like the pipeline of the game. So we prepare the project, we structure the folder files and everything, and we even implement some fundamental code blocks and start integrating some libraries so that the production can actually pull off. So then it comes the production, right? So this is this longest phase. It lasts between 4 and 9 months. It really depends on what type of the game are you making. So, but those big games, it's usually towards 9, 10 months. So this is the delivery of all those features that we specified in the GDD, and we decided to implement them. So the UI, they draw assets for the UI. 3D assets are being modeled. animators animate characters and stuff like this. Programmers write the code, and everything is then being integrated in the game and to make it functional and tested. So this production phase can be broken down in several soft launches. So why we're doing this? So we want to implement something like a vertical slice, and then publish this soft launch to the store to early get some info from how it works with the end users. So we learn out of it a lot, and then we incorporate those learnings into the production, and then we decide whether we do another soft launch. And we literally iterate this until we are happy and we improve those KPIs in order to then bring the whole thing to the global launch. So this is this major milestone, and we deliver by then the rest, and we publish it globally. Full swing with the global launch, with the full marketing campaigns that comes with it. So on average, it takes around more than a year to fully release a game worldwide. And the duration of each phase, it really depends of the type of the game we're making. And usually for this new IP, new genres, this tier of games we do usually involves more soft launches, even up to 6, right? So the genres we know already might have like 1 soft launch or maybe 2. So when the game is on the store, then we move with the updates. So these are shorter cycles, 1 to 3 months, and the objective is that we constantly deliver new content, new features to the players. And we process the feedback after every submission and try to learn out of it, and then we even decide like which features are we going to implement in the next updates based on what works, what we believe, or what we figure out that the players want to play, and this is then decided to deliver in the future updates. So we always strive to make the games reach this live ops phase. So we plan to implement some features in such a way that we don't need anymore the full R department, tech department to implement them. So we deliver just assets from backend in order to reskin some events that last maybe over the weekend or specific holidays, like Halloween event, right? So we call this phase live ops event. And the team hands-on the project really works on some technical improvements, but the rest is delivered remotely so that the whole team that was busy with the game making it can already move to the next game and start doing it all over again. New game, new genre. So when games become really like late in the production phase, when they reach there, we call this tech updates phase. So we don't really update even or make those live ops events. So we just keep them alive on the store, like in the autopilot mode, and we take care of stability so that it just stays there, right? Okay, so how this works on the project, so this how we operate aspect and how we are organized on the project level. So we define 2 weeks long sprints in Jira. So it's a tool where we track our tasks, and we have those things for each department. So art meets and aligns. So we have those daily things, right? And tech as well, and PUG, so product, UX, and game design. We regularly meet together to find solutions in the discipline for the pipeline. And also, apart from that, then we, when the production starts and it's already mature, more focused towards the feature things. So we have them once per week. And this is organized into teams per feature that really works hands-on. And they meet cross-discipline, so developers, also QAs, 3D, VFX, so everyone that works on each and every feature. And it really depends on what kind of feature it is. So for gameplay, there is usually no need for UI. So those disciplines are included there that make this feature. And apart from that, of course, there's a lot of ad hoc things for specific topics. And for communication, we use Slack, and every team, every project has its own channel, but also this feature team has its own Slack channel there on the project. So there we really elaborate cross disciplines, hands-on on every subject together, and also product managers, manager is in there, art lead, tech director, and we elaborate together there on a feature basis on stuff that pop up day by day. Okay, then we have also some milestones. For example, we do regular play tests. So we are organized in such a way that every Thursday, the whole team on the project meets cross disciplines, and we play the game in this phase, and we figure out how it is. So we go into this mode of like being the users and to see what is this awesome content that we are making. So we also gather the feedback. So as a team, we really try to figure out how to make further enticing this very feature, how to squeeze out of it the most. And then we also gather the feedback. So pretty much out of this contribution of the team, the product department then reviews those feedbacks, and we even incorporate this as we go into the production plan and make further as a team those improvements in the feature before even we put it out to others or even to the store. Then we have the wrap-ups. So this milestone serves as a feature complete milestone of a very feature. So by then, we expect that the feature in a nutshell is functioning. So you can try it out. You can play it. It's not bug-free and polished, so this comes afterwards. And then we have the user tests. So we organize ourselves during this production phase to have 2 or 3 user tests. We prepare a build, and we give it out to a small group of end users, like 20, 30. We can even, sometimes we do it online, it's even more. So to see if this end audience understands the tutorials, if they understand the gameplay, if it's too hard maybe. So that we get, again, early, before even doing a soft launch, some intel that we can fix those features and make it even better, better performing. So then we have like a major milestone feature complete for the whole production of the game. So by then, like all those features have to be in this working stage, and we just go into polish, bug fix. So this can be between 1 or 2 months long even. And by then, in this time frame, we have to make the game ready to be released or submitted to the stores. So then we go into the code freeze mode, and here we still leave like for 2 weeks that the game is just like gets super stable, and we just fix some bugs that might pop up there before we even go to the stores. Yeah, we do also company testing. So when we are somewhere there before, so around, let's say, feature complete, we give it to everyone in the company to play. So our like 400 people play a game to give feedback. So we really then expose this on a company level, so everyone can pretty much then say what is really bothering them, and then we figure out what is the most disturbing thing, then we quickly fix it before even going to the store. Then also on the project we have, of course, retrospectives. So every 6 weeks or so we meet with the whole team, and we share like kudos to each other, and we define areas where we can do better, and then we define action points, how to incorporate this, and to improve processes as we go also as a team, right, how we cooperate. Okay, so let's now continue with the roles. So now we will discuss about the software engineer role. And so who is a software engineer in a gaming industry? So usually this engineer is proficient in C# or C++. We say devs, right? It's shorter. And devs have experience also in, of course, in a game engine. We also use Unity in our company to make games. Aside from that, we developed an in-house game engine. And why we did this? So back in the days, we wanted to have like more control over how assets are being loaded, how physics is functioning, and also we wanted to improve to make faster loading the game and when you switch the scenes. So back then, Unity was not that fast than today, and also we achieved to make smaller app size. So today we're using our in-house game engine for our Tamagotchi games, and we also developed our own editor. So you can imagine this is really a lot of work. And recently, Unity is really good, improved, and all of that. So we decided for the new games, we will just be using Unity. So games are really performance critical, right? So the knowledge of a developer really rotates around those aspects. So especially on mobile, the mobile devices are less powerful than desktop or consoles. So we want to really design and develop games to look as beautiful as possible, and at the same time to still run smooth with least glitches and stutter as possible. So a really important aspect is devs study how device memory works. So even on a hardware level, how it is organized. So to see it as for example, hard disk, the external or permanent memory, it's the slowest and the biggest. And then to understand that the primary memory of the programs that run on ROM, as we refer to it, it's faster, but it's smaller. And then the processor's cache, and there's also the registers. So a developer studies this and understands to the hardware level, and how, when a developer writes the code, how this is managed. So how organizing the architecture and the code to use, I don't know, good practices about data locality and how stack and heap work, and also understanding, so when you use some data structures, how fast are they and which ones are the best to use for your problem that you have. So a developer studies this. And then there is, in gaming, the game programming patterns. So these are the programming patterns or techniques that teach how to properly organize the code for games, and also about the techniques how to implement specific behaviors, for instance, firing projectiles and destroying enemies, in such a way that the approach itself prevents creating bugs or crashes. So it's about those techniques. And it really steers also the development of the game into this efficient use of device memory. And all of that makes then the game run smoother with higher FPS. And also the pattern teach about how to make game in a scalable way. So you really want to organize everything based on what game you're making, that you can add fairly quickly new levels, new worlds, new features, and all of those patterns are really cool. And there is also this book by Robert Nystrom that you can also look online. It's available, about the game programming patterns. So apart from everything like programming for a developer, it's really important to gather knowledge of actually other disciplines. And it's from this perspective of the technical aspects, of course. So most often, the work of a developer on a game is to provide a solution to some other disciplines, so to solve some challenges that other disciplines have. And like assets are prepared in design tools like Maya and Photoshop, so they are then used for implementation of the game features. And this can come down really to a lot of assets, a lot of animations, a lot of textures and all of that. So programmers make the tools that other disciplines use, for example, to import those assets in the project. So there's a lot of attributes and parameters that you can even like play with to have like to use proper compression algorithms and stuff like this. And you really want to have this automated. So artists, they want an environment where they work on 3D mesh and animation and then they just put it in the game, and they continue working on it, and then they just refresh this very asset. So everything else, the structure, those parameters, it has to be intact. It has to be bulletproof. So you need like a developer that implements this process of how this comes into the game. And if this is done right, it really avoids those mistakes of using some properties, having them on, forgetting about this, and then it makes the game slow. So you really want to have like a very thorough infrastructure for to support importing assets into your game. Okay, so another aspect, of course, everyone pretty much comes to it, is the computer graphics. So a developer gathers, like over years, probably a very solid understanding of how computer graphic works. So it's this knowledge about the rendering pipeline. So how a vehicle in the form of a 3D mesh with maybe some textures is like rendered on a 2D canvas, 2D screen from this out of this 3D world. And there's even involved into this knowledge is all of those different techniques that you can use to make a vehicle show up on the screen. So maybe it's not textures with the mesh, maybe it's just like painting those vertices to show it up, or maybe something in between. So this knowledge also of shaders and different techniques, it helps to find this proper approach of first having this design. We want to see this in the game, and it's functional, looks nice. So how can we achieve this, right? So these things then really help to find those different approaches so that it's fast and appealing, looking appealing. So also regarding math, of course, then comes to down to the calculating vectors or transformation in 2D or 3D space. So sometimes you're rotating something, writing scripts for this, or you're skewing something, and all those things come to some math in this aspect. So the programmers, when they implement fundamental logic, at first maybe with the white boxes and some mechanics, so the feature in a prototype-ish way works. Other disciplines then also they have to bring in, let's say, on VFXs. So we call this that we hook VFXs, let's say, with the gameplay. So programmers spawn particle systems or run animation curves to support the work of VFX artists. And when this is hooked, then at the beginning the effect looks crappy, but VFX artists then can continue to work on this own particle systems and further tweak it in order to then bring it to the final visual touch. So for animating characters, developers create animation state machines, and it looks something similar like this, and help hooking those animations done by artists so that we achieve this desired movement of the character or moving obstacles there in the environment. So then there's of course the UI. So developers make, let's say with own code, so they connect those dialogues so that they show up. They animate them. We have to animate them to come in, I don't know, from the left when the UI is animated. And all of this UI, it has to be somehow organized. So developers help organizing them into atlases for performance reason. And developers use this Unity layout and anchoring system. So we want to have the UI to adapt to different aspect ratios. So you can imagine on Android, there's so many different devices with so many combinations, and it really has to work and be functional for all of those combinations. So it's quite a challenge. And also to make UI in motion, we, for example, developers hook up some timelines, so then artists continue with tweaking those timing and adding maybe some particle systems even, so that this comes to life. Also UI, also sound artists, of course, hook up some sounds, and everything starts from the developers to hook and glue everything that then artists can finish up their stuff so that it really gets this final touch. So some more things that developers cover, just to give this impression what this involves. So we want to support different languages. So our games support about, it's actually 12 languages. Technically it's 13 because Chinese has traditional and simplified Chinese. So we want to hook those texts just with some IDs that the translators then translate all of the actual text in some external tool. And then we just refresh those translations in, right? So the games, they just use some IDs, and developers hook this up. They even implement some bridges between those external tools, so they'll also support translators. And Unity is, as a game engine, it provides really out of the box a lot of components to achieve such stuff. Then, of course, we use them in our processes to implement it efficiently. Then there is the analytics events. So you can imagine the game has a lot of actions, and you can interact with it in so many different ways. So we hook up also those analytical events with the help of devs, and we track a lot of actions that users do in the game. So we want to learn, let's say, to which level they come, so how many character skins they unlock, which characters they prefer more over the others, which funnels in the game are not even discovered. So sometimes we put design a super awesome feature in there, and this feature is not really discovered by a lot of users. So we want to learn about this when the game is on the store, and we want to then analyze all of that to figure out how to further improve. So devs really hook up plenty of analytical events all over the game. Then we have also the custom editor tools. So we need to implement, let's say, those tools that level designers and also artists use to even create this content in the game. So this can become really complex. So here's just a quick example from Gold Run 2 that we are currently making, and it's in soft launch. And these tools allow also artists to create some building blocks that then level designers just put into the levels, and also create environments out of this. And this thing can come to 4 months programming, just that you have this level editor with 1.5 engineers created and useful. Then we have also the libraries. So of course, having a lot of games in the company, there is a lot of code that you use on all of them, but you don't want to copy paste them. So this has to be somehow properly organized. So in our company, this came down to having the whole iOS department implementing the iOS stack with this common code, and the same for Android, so that we then can use this in all of our games for very generic functions like in-app purchases, for instance, or talking with the backend infrastructure. And then also for just this code in Unity, you also have some generic code, and this is organized into some packages, Unity packages, or some libraries, and there is like teams that work just on this to provide this common functionality, so that we can then just use it in other games and avoid copy pasting, right? Because then it's super hard to maintain this if it's on so many different places. So yeah, remember, we have also this in-house game engine, and we had to write also all those libraries also for this in-house game engine. So you can imagine how much of an additional work this is to make own game engine and use it for your games. So really think about this. In a big company, you have to really know why are you doing this. So I think that you got this impression that it's so interesting because a developer supports goes into so many areas, because you have to support so many different disciplines, right? So bear in mind that a software engineer doesn't know everything what I mentioned. Even I just scratched maybe some areas or knowledge. So it's a lot more. More or less, like you gather this knowledge with experience working maybe on a game on UI, and then you move to gameplay. So this gathers over years. And remember also, I would like to express this, that you really never stop learning. So after being 10 years, 20, 30 years in the industry, there's so many things, and so many new things is coming up. So everyone really learns throughout the professional journey. So I personally had to catch up a lot. So you can imagine, before I was in some IT or working as a full stack developer, then I joined gaming industry. So for me, it was everything was like from scratch. And yeah, don't be afraid to make bold moves in your career. So follow your passion, and have in mind that everyone really has this step number one. So let's move on to the second role that I would like to talk about, and that's the quality assurance engineer. So to give a bit more info what it means to be one. So who is a quality assurance engineer in gaming industry? So we also call them QAs, or tester to be short. So QAs test the game features to ensure that they are working right or not. If not, they report bugs and glitches in order that other disciplines that implement the features fix those bugs. In our company, we use Jira. So it's this bug and task tracking system, pretty much standard for the industry. And as I mentioned, teams across all other disciplines like devs, 3D, UI, VFX, animators, and sound, so they might create those bugs, right? So QAs reporting the bugs, it's for all of those different disciplines. And remember back, we were discussing about the soft launches and global launches. So we are really not that picky when we do soft launches. We even leave some glitches in there, knowing that they're in, because it's okay to bring the game into this state. That is cool to test it out, bring it out to the users, learn out of it something. And for global launch, we're really picky. So here, QAs really go into details. We want to polish the heck out of the game and make it like as sleek as possible. So here, QA opens up tickets for a lot of small stuff. So QAs, they start joining a project somewhere after pre-production. So when the production starts, one by one, it scales, not instantly throwing 7 people there, but it goes with how many features start getting into implementation. So on average, for let's say every 2 developers, there's one QA. And so to give a imagination, so a big project in the busiest time of the production, there's about 14 developers, but that's just for working in Unity, right? So apart from all those backend and native departments, so 14 developers and 7 QAs. And then when later in the update phase, everything is scaled down, there can be like just 4 developers supporting the updates phase and 2 QAs. The rest already switched to the next game and to start all over again the whole process. So in our company, QAs are really part of the project's team. So we don't have like a pool of QAs in the company that works on different games. So if you're a QA, you're assigned to this team, to this project, and you're working hands-on with the devs and other disciplines and joining those meetings. So you're really part of the core team. So about the skills and abilities of a QA. So QAs really develop this attention to detail. So when they go through the specs, they really thoroughly studying the GDD and how the game should look like. So they go through game features and try to understand everything, how this should work, how this should look in the final stage in the game when it's implemented. And for the visuals, they are also discovering those visual glitches and irregularities. So they have this eagle eye perspective, how to call it. Our QA is also very strong in communication with other disciplines. So when you gather info and try to understand how things work and get more info from other disciplines, they collaborate a lot through disciplines. And when they spot issues and problems and bugs, they again reach out. So it's very communication heavy position actually. QAs are really tech savvy. So they know mobile platforms, they know different vendors, and then they also distinguish. So for example, of an operating system and those advanced settings and stuff like this, how to, I don't know, use the debug mode on Android, install third-party apps, and the store specifics. So they know the ecosystem, they know the specifics of App Store, Google Play, Game Center, how it works, eOps, and stuff like this. And they really get proficient with some external tools that we use in the production to study data, to see charts and patterns when they study crashes, and to study the game vitals. And QAs also read logs. So they download device files, they attach with Logcat with a tool, and then they see at runtime the logs, and they also collaborate with devs to request, I don't know, give me some more things in the log so I can see what is going on with the game and have this, let's say, info under the hood, right? And they also go into understanding the stack traces. So when the game crashes, we gather the stack trace, and QAs can differentiate by just looking at the stack traces, like what can be the potential cause. They then also figure out if this stack trace is old, we already fixed it, so they really go into details in this regard. QAs also develop this, we call it the breaking things mentality. So when you're a tester, you really want to find those unusual combinations and flows and think out of the box and consider, I don't know, double tapping. Let's say kids, when they hold an iPad or some tablet, and they play the runner, so they might accidentally, with the left thumb, like hold the screen, and then they run, right? So the game has to function really flawless, even in this regard. So when you then release the thumb, it still has to function. So it's a lot of such corner cases that QAs go really deep into and try to find them. What happens if you press on Android platform back button, like somewhere in the middle of the animation? So you really then have to check this for all those flows and have this in mind. So also testers, they try to see this big picture. So I mentioned earlier all those different disciplines and departments. So in a big game, there's a lot of complex system in play. So we have, let's say, on native, this Android and iOS implemented the customer support. So we just integrated in Unity game, right? So when you test something like this, so there can so many other things go wrong, like something how we tank those backend configurations. So QAs really establish this overview, and they try to find this corner cases and stuff that when one subsystem can have a problem and causes some other system not to function. Yeah, they really understand this in the bigger picture. So also there's one thing that I think is super cool to mention when we talk about QA. So we can really never prove that a bug does not exist, right? So as a QA, you have to have this in mind, that only what you can prove is that the bug exists if you find it. So if you manage to find it, you can prove that everything else that might still exist, but you haven't found it yet, so you cannot prove that, right? So QAs are really always on this hunt of finding these reproduction steps. So when something happens, you have to really know what happened before, what the user did. So as you work as a QA, you also want to establish such a system and workflow when you get in some reports, to see screenshots, to see detailed descriptions of what other colleagues in the company were doing in the company test before the game crashed, right? So yeah, it's about finding these reproduction steps, because when the bug is fixed, QA then repeats the same reproduction steps, and if it's not happening, then only you prove that no, okay, the bug is fixed, right? But there are still more bugs that can exist, but you haven't yet found them, right? So that's why I said you can never prove that the bug does not exist. Okay, so about responsibilities of QAs. So I think I mentioned earlier, said they really study the GDD. So QA, they have to understand completely the desired flows and features, how they're going to work when they're going to be implemented. So QAs also challenge the decision behind this, and we have this work mentality that is very open and approachable, and QAs also challenge when something was, I don't know, not designed very well, or they're missing specs, and when they found corner cases, so they communicate this to other disciplines. So QAs participate right from the kickoff meetings. So when each feature when we start developing it, then the whole feature meet syncs. And QA, since beginning, is there in the story, and we put every task that we are about to do cross disciplines in Jira, and QA is really watching the progress. They check along the way what is going on with the feature, to give feedback, to really prepare, and also to make the test plans. So this starts really early, and some features, for example, what happens if you run something in offline mode? We store, let's say when you play the game and just kill it right away, do we properly store all those, the progress and the things in the user prefs? So it depends really on the feature, but usually QAs prepare very specific test plans up front from the beginning. An important aspect for QAs as a tool is the debug menus. So you really, as a QA, want to, I don't know, get a lot of, plenty of currency to not be stuck with this, right? So if you test world number 6, you don't want to play all of the worlds before. So as a QA, you start thinking, what do I need? So when I will be testing the feature, what are those shortcuts? And then QAs request this from developers to get all of those shortcuts implemented. So sometimes debug menus in games look really complex, right? So this one is even kind of in the early stages, and that's super important thing. Then QAs, of course, test all the implemented features. So literally every task that we define for a discipline to do, when the Jira ticket is resolved, a QA tests it if it's working. So every task. And then we have also the test automation. So when you have a very tedious work, so I will give an example of localizations. So you have 12, 13 languages. You don't want to, as a QA, you want to check if somewhere the text is overflowing from UI, or it's not properly displayed because of being too long, like German words are super long. So what do you want to automate this? So we have a tool that runs automatically through all of the screens, language by language, and makes screenshots. So QA then just can go through the screenshots, it's so much quickly, and see if something is visually broken. Then QA is also prepared to build for all those milestones that I mentioned earlier. So they have to confirm that we even can carry out a play test, right? A user test. So they are this, you can call it as or look at QA as the last line of defense. So the game really cannot go even to our team to test it if it's broken. Then you can imagine for a store submission, so QA really is the last one to give the green light and tests everything, and then only let's say a tech director can say. So tech director asks even, hey QA, do you give a go to the game to go to stores? So because they check everything, right? Yeah, QA is also a very important role, and I think that's about that's about it. So now I would like to briefly talk about our culture. So this is even, I think, for many gaming companies, like a topic, right? What is the culture about? And yeah, in our company, the culture is one of the most important aspects, and it's our people. It's how we put, how we do things, and how does it feel to work with this awesome team members. So we have, for an example, one thing in our company, No Limits Award. So everyone each month can nominate a colleague for doing something extraordinary, help someone or organize a social event, and the commission then evaluates all those nominations and picks a winner. And this winner gets one additional day of vacation and a financial prize. And his or her name is also put on a special wall. So let's take a look at a super short video.
I'm very proud that my name is on the wall. I just remember like that moment when I received the No Limit. Whenever I bring my friends here, I can like brag about it, like, oh, see who's up there? There are other names on the wall.
I don't know who these guys are.
I guess the war is gonna be so big in few months.
You cannot get this by money or by, I don't know, by buying stuff online. You connect on the deeper level with somebody else.
I hope we always see these special moments, these little things that actually affect our day-to-day lives. Even if you don't put it in a No Limits award nomination, maybe just sit down with that person and thank him or her for making your day extra special. Everything can happen. No Limits is really not just the award. It's about the connection between what we can give to each other, and for me, it's what makes Outfit 7 really special as a family.
People are really so nice, taking care of each other and helping each other.
People go out of their way to help you whenever they can.
The culture here and the spirit that's in the company, I think this is amazing.
All right. So I think I'm too loud. All right. No, I think it's better now. A couple of moments from our offices. So we really believe that to make an awesome content, an awesome game, you have to have fun, right, while making the game. So what can happen is that sometimes some other team storms your team with the Nerf guns, and then like a Nerf battle happens, right? So also about those test sessions, this photo is pre-corona. And yeah, those are super cool sessions. So with so many games, you really in a month get together with your team to test some other team's game and give feedback, report bugs, so the games are more stable and more those ideas are incorporated in. So those are also super fun. And yeah, in our Barcelona office, you can encounter also a dog or two. So this is also a super cool thing to cheer up. Being there with this awesome team and working in such an environment. And of course, we have also, let's say, these fun rooms in our studios. So while working, you can take some time to relax and to go with your teammates to play some footballing, some ping pong, or games on PS5, or treat yourself with a popcorn machine. And there, of course, is also this awesome thing, the team buildings. So it's just so priceless to work like the whole year with your team members, and then have this team building and get together and have some awesome activities and an awesome party. We actually do this twice per year, and at the moment we do this per office, so local/remote, according to how the situation allows. this video is pre-corona, but let's take a look how it looks. So everyone traveled to Ljubljana, and we went, so from all studios, we went somewhere, booked the whole place, and had awesome time there, activities, and an awesome party. Let's have a quick look. All right, so we came to the end. Thank you everyone for listening. And before we move to questions, let's mention also this. So let's get connected on LinkedIn. So there are some QR codes. Follow Outfit 7. So we post regularly job posts, potential internship programs, summer camps we had in the past, how our games are doing, and give some sneak peeks in our team buildings. You can also add me on LinkedIn to get connected. Check our website, job posts, and info about our games. And also there is this YouTube videos channel, so the last QR. So that's it.